Everyone, Mr. Victor here, and welcome to the Science Student Network videos. We will be discussing chemistry, and particularly the topic that has to do with the covalent bond. This is in response to the question of the week posted for the Science Student Network 2. Those in that particular network 1, those in that particular group were asked to explain how a covalent bond is formed. And in simple terms, that is exactly what we are going to find out today. So let's quickly move into the business of the day, the covalent bond. Now, the question may come, what is a chemical bond? And why do bonds exist? Well, the fact is, we can see a bond as, or we can describe a bond as a force of attraction that holds atoms together. So, first you have to understand what a bond is. A bond is usually seen as a force of attraction that holds atoms together. Now, the reason why a bond should exist in nature is simply because every atom wants to attain their lowest possible energy. You know, most of the atoms are unstable in nature. As a result of that, they have to combine with other atoms so that they can achieve stability. That instability, the initial instability possessed by some of these atoms or elements, makes them reactive in nature. And as such, they seek other ways to become stable. And in their quest of becoming stable, they form bonds with other atoms. They become attracted to other atoms by the formation of a bond. So that is why we say that a bond is usually seen as a force of attraction that holds atoms together. Now, there are different kinds of bonds or types of bonds. We have what is called ionic bonds. So we're saying that certain atoms actually form bonds by either the giving or the receiving of electrons. All right. In this case, we're looking at the covalent bond. The covalent bond is usually formed by the sharing of electrons between two or more atoms. So, for the case study, a covalent bond is formed by sharing of electrons. So the key word here is the sharing of electrons. Now we're going to see how electrons are being shared among atoms in a covalent manner in this video. So let's get on with it. Now, we are going to consider covalent bonds in this fashion. We are going to consider what is called homonuclear covalent bonds and heteronuclear covalent bonds. Now, do not worry too much about the use of words here. Homonuclear would simply mean the bonds that are shared between the same atoms. Okay, two or more of the same atoms. Whereas heteronuclear covalent bonds will be bonds that are formed or that are shared between two or more different atoms. Okay, so a covalent bond itself is an interatomic bond, meaning bonds that are formed between two or more of the same or different atoms. Interatomic. Remember, when atoms combine, they form molecules. But in this case, we're looking at the bond that is holding two or more atoms together. Now, these bonds holding two or more atoms together could be the same or different. If the covalent bond holding two of the same atoms together are present, it's called a homonuclear covalent bond. Whereas the bond holding two or more, the covalent bond holding two or more of different atoms together is called a heteronuclear covalent bond. Okay, so let me give you an instance. Atom A and atom A held together by this pair of electrons will form what is called a homonuclear covalent bond. Whereas atom A and atom B held together by this pair of electrons forms what is called an heteronuclear covalent bond. Now, a bond itself usually exists as electrons. Okay, so in other words, these outer electrons that is being that is being shared by two of the same atoms here, A in this case, can be written in this form, A and A. I am just trying to say here that these electrons that is holding A together is equivalent to this. You can also write it this way, meaning that a bond here represents, a covalent bond here represents two electrons or a pair of electrons. So I can also write this in this fashion. Okay, so a homonuclear covalent bond, like we've already explained, is a bond that is formed between two of the same atoms. In this case, we are using A and A as an example. While a heteronuclear covalent bond is a bond that is formed between two different atoms. Okay, so in this case, we are using A and B. Right, so we are going to take examples of a homonuclear covalent bond in this video. But before we do that, there is a key concept that we need to understand before we move further. And that concept is called Lewis dot structures. Lewis dot structures. Now, what does this concept talk about, Lewis dot structures? Well, Lewis dot structures are very important in explaining covalent bonds because a Lewis dot structure actually describes the outermost shell electrons or the valence electrons of certain atoms. So in Lewis dot structures, the outermost shell electrons are represented as dots around the atomic symbol. In Lewis dot structures, the outermost, what you call valence shell electrons, are represented as dots. You know what a dot is, of course, around the atomic symbol. So if you understand the concept of Lewis dot structures, which we are going to see in this video, then you can go ahead and explain how covalent bonds are formed homonuclear, in an homonuclear fashion, or in an heteronuclear fashion. So for Lewis dot structures, you represent the outermost electrons as dots around the atomic symbol. So let us take an example of what we're talking about. To understand this fully, you have to also get the concept of electron configurations. Okay, for the first 20 elements, let's just say hydrogen down to, let's take the first 10 to neon. You will remember that hydrogen has a configuration of 1, meaning it has 1 outermost shell electron. Helium has a configuration of 2 outer shell electrons. Lithium is 2, 1, and this 1 represents the outer shell electron. This is the first shell, this is the outer shell. Beryllium is 2, 2. Just giving you a recap, okay? Boron is 2, 3. Carbon is 2, 4. Nitrogen is 2, 5. Okay. Oxygen is 2, 6. Fluorine is 2, 7. And neon is 2, 8. So these are the outermost electrons, the ones underlined. And we are saying that for Lewis structures, the outer shell electrons, that is these valence electrons underlined there from these configurations, are represented as dots around the atomic symbol. So there is a pattern of writing this. You start from the right hand side of the atomic symbol, you go up, you go left, and you go down. Take note, right, up, left, down, right, up, left, down. Let's take an example. For hydrogen, 1 outer shell electron would mean 1 dot. For helium, 2 outer shell electrons will mean 2 dots, but 1 up, 1 right, and 1 up. And for lithium, it has 1 outer shell electrons. It means I will be writing just 1 dot by the right hand side. For beryllium, it is 2 outer shell electrons, meaning I'm taking 1 up, 1 right, and 1 up. And for boron, it is 1 right, 1 up, 1 left. 3 outer shell electrons, 3 dots. For carbon, it is 4 outer shell electrons, meaning 4 dots. So, in this situation, I start all over again. And for nitrogen, I'm going to be having 5 outer shell electrons, meaning right, up, left, down, and right. In this situation, I see a paired electron here, and I see 3 unpaired electrons. That will take us to another concept, which we'll be explaining in subsequent videos. And for oxygen, 6, 1, down, down, and there. And for fluorine, it is 7, 1, 2, 3, 4, 5, 6, 7. Okay, so it has 3 paired electrons. For neon, 1, 2, that is 8 outer shell electrons. This is 4, 5, 6, 7, and neon's electrons are all paired. That gives you an idea that neon is stable. But the fact that all its valence electrons are paired, it means neon is stable. But if you look at some other atoms here, some of the electrons are not paired. That is why some of them will appear as unstable. That is the reason why some of these atoms will have to form a bond with other atoms so that they can achieve stability. So in the next video, I'm going to show you, I'm going to use this Lewis dot concept to explain homonuclear bonding and heteronuclear bonding.